Kiersten Formoso. She is a PhD student at the University of Southern California and the Natural History Museum of Los Angeles County, and she will be talking to us about mosasaurs today. So, without further ado, Kiersten, you can take the stage.
All right, thank you so much for that great introduction. I'm so excited to speak to everyone today. So let me move my PowerPoint along. All right. There we go. So yes, today I'll be talking to you about mosasaurs, and I'm over here in Los Angeles. It is 11:01 my time, and I'm so happy I get to start my day off with this. So about me first. So my name's Kiersten Formoso. That's me there in the field. I grew up in Sussex County, New Jersey. So for the New Jersey people who are watching, I am from your neck of the woods. I love my state. I graduated from Rutgers in 2016 with a degree in ecology and evolution. There's Block R. And currently, yes, I'm a PhD student studying vertebrate paleobiology in the Earth Sciences Department at the University of Southern California. And as well as that, I'm also a graduate student in residence at the Natural History Museum of Los Angeles County, also known as the NHMLA, which is conveniently located actually right across the street from USC, which is where a lot of my data is housed, including mosasaur fossils, some of which I will show you. And a fun geology fun fact about myself is that my favorite geologic time period is the Triassic period. Feel free to ask me about that at the end. And so again, I'm so excited to talk about mosasaurs. They are my favorite extinct animals. They are not dinosaurs, which I'll get to that in a moment. And without further ado, let's get into the main substance of my mosasaur intro presentation. So mosasaurs have kind of captured the imagination of naturalists and people who love prehistoric creatures for actually a couple hundred years now. Their fossils are really old. This beautiful art by Charles R. Knight from the 1800s shows a Tylosaurus hunting some big zybactinus fish. And then more recently, the mosasaur kind of group has gotten attention, big dramatic attention in Hollywood movies like Jurassic World with the very, very large, oversized mosasaur featured here. But I personally loved it because it's cool to see my study group, which of course are not dinosaurs, be featured in a big Hollywood movie. And so what are mosasaurs? I've said a few times that they're not dinosaurs. Well, they're actually extinct squamates, and so they're lizards. So they're in the same group as all these types of lizards. So this is a mosasaur featured here. And snakes, which are lizards. Snakes simply lost their legs a long time ago. And then Komodo dragons and modern lizards. And if anyone has a pet bearded dragon at home, your pet bearded dragon is in the exact same family as mosasaurs, which is one of the reasons why I love them so much. And we know they're lizards because they have really distinct anatomy that puts them in the same group as lizards. And paleontologists call these anatomy features characters. And so they're characters, features of how their bones are and other features that unite them with other closely related animals. And as it so happens, mosasaurs actually share a lot of characters in common with snakes, which is what leads most paleontologists to agree, for the most part, that snakes are actually mosasaurs' closest living relatives. Even though mosasaurs have legs and snakes don't have legs, snakes' ancestors did used to have 4 legs as well. And so some of the anatomy features also that unites mosasaurs with lizards and snakes are these features called pterygoid teeth, which I circled there. And it's basically just the kind of inner row of teeth that some lizards have, which is very distinct and really cool that mosasaurs had double teeth rows. I would not want to mess with one at all. And so when did mosasaurs live? Mosasaurs lived in the late Cretaceous period of the Mesozoic. The Mesozoic era is kind of known as the age of reptiles, the same time that many interesting reptiles like terrestrial crocodiles and also when dinosaurs kind of rose to prominence in the world. And the late Cretaceous is right here. And so specifically there, which is mosasaurs lived about 95 to 66 million years ago in that, give or take a few million years. And the latest lasting mosasaurs actually lived at the same time as famous dinosaurs like T-Rex and Triceratops. Of course, in the water, these were on land. And they went extinct at the same time as the dinosaurs when the asteroid struck the Earth at the end of the Cretaceous. And so if you zoom into the late Cretaceous, mosasaurs, and these are the earliest mosasaurs, but ones that barely looked like the ones that we think of when we think of mosasaurs, appeared right here in what's called the Cenomanian age, and then went extinct right at the end of the Maastrichtian. So they had a short little geologic time span, but of course it was enough time for them to kind of capture our interests and our hearts and minds. And so mosasaurs started really small, actually. They looked pretty much like aquatic lizards because that's what they were, tiny, a meter long, a little bigger, a little smaller. This is a mosasaur relative called an Agialosaurus. And this is the skeleton here, and this is reconstruction. So it doesn't really look like the big kind of finned mosasaurs that we're used to. And then even kind of the earliest mosasaurs, this is a very early mosasaur with very primitive features here called Dallosaurus, so named for Dallas. It was discovered in Texas. And this was the size of that. But of course, through mosasaur evolution, they had the opportunity to explore different ecological spaces in the ocean, different regions, and they got huge, some of the biggest marine predators to have ever existed. So you have ones ranging here like Halosaurus, which was a little bigger than a human, to this one here, which is a Mosasaurus hoffmanni, which is the name animal that inspired the name for the whole group of mosasaurs, maxing out at like 50 feet long. So they really got large from very kind of small, humble origins. And so mosasaurs live globally, actually. Their fossils have been found on every single continent, including Antarctica. In the United States, we're very familiar with mosasaurs from the East Coast, including places like New Jersey, and then also areas in the Western Interior Seaway, which was a shallow sea that went from the Gulf of Mexico all the way up to the Arctic. And so we get mosasaur fossils in the middle of land, like Kansas and places like that. And then also mosasaurs in California, some of which I study. But we also have mosasaurs in South America, in Asia, in the Middle East, lots in Europe, and even some from the Arctic and Australia as well. And so what did mosasaurs eat? Well, you can guess that they were probably predators, given their big sharp teeth, and that is exactly what they were. They really ate whatever they wanted, especially the large ones. They probably had few natural predators except other mosasaurs when they were young. And so they ate fish, sharks, ammonites, plesiosaurs, which are other extinct marine reptiles, birds of the time, turtles, and even other mosasaurs. I show here these kind of weird teeth of a mosasaur called globidens, and it's inferred that it used these very strange bulbous teeth to crunch ammonite shells. And so this is kind of a menu selection for what mosasaurs would have been eating. So these very huge fish here, these short-necked plesiosaurs, early birds, Hesperornis, that actually had teeth, and then ammonites here for the kind of shell-crushing mosasaurs. So mosasaurs were big, dominant ocean predators of the late Cretaceous. And we know this actually, which is even cooler, is because we actually have fossils with stomach contents from mosasaurs. It's hard to tell here, but this is a mosasaur called Prognathodon. This is the vertebral column. And in the stomach here, it's actually, there are 3 skulls. In this picture, it's easiest to point out this one here and this skull as well, but there are 3 if you look closer. But either way, it's a mosasaur fossil that has preserved stomach contents, which is amazing. And so what do mosasaurs look like? Well, we have a general idea in our head, you know, a big swimming marine reptile. But mosasaurs had a tail fluke. There are different, ideas for how big this tail fluke was, what the exact structure was, but they did have one, definitely have one, these big mosasaurs, enclosed paddles and long streamlined bodies. And this beautiful reconstruction, one of my favorites by my friend Scott Hartman here. And we know mosasaurs have this because we have the amazing fossils that show this. This paper that came out in 2013 shows the paddle outline of a mosasaur, which you can see here. So it has enclosed fingers, but the fingers aren't individual, kind of like a whale, where it's enclosed by a paddle. And this specimen is really, really cool because it shows the tail fluke outline there. So you can see the tail fluke. And so mosasaurs have great preservation, probably because they're marine animals. When they die, they sink to the bottom and they get covered with a sediment, which is gives us a lot higher likelihood of finding them as fossils millions of years later. And this is a really great specimen that we actually have at the Natural History Museum of Los Angeles County, and it's one of the specimens that I'm very fortunate to be able to work with. Beautiful skull preserved here, which includes skin impressions on the head, and even those little tracheal rings, so essentially the cartilage preserved from the windpipe of the mosasaur. So it's really, really amazing preservation. And it includes mosasaur skin if you look up closer. So here we have the scales of the mosasaur, which further shows that they had scales, just like modern lizards do today. So it's really cool that we have a really nice picture of what these animals actually look like, even though they lived millions and millions of years ago. This is another really beautiful fossil. It actually has fish contents in its stomach, but it's just outstanding. The skull is perfect, and you even have the paddle here. So I really, really love this specimen. It's gorgeous. And this is a kind of full reconstruction, what paleontologists make that you'll see in museums. They'll fill in some of the gaps using other mosasaur fossils, but honestly, so many mosasaurs have been discovered so completely that we really don't need to fill in that much of the skeleton when we kind of mount them, which is really a nice treat as far as these extinct animals go. And so artists have a wonderful field day with making these beautiful reconstructions of mosasaurs here, like this beautiful art by Mark Witten, showing them looking very whale-like with big tail flukes and lizard-like kind of skin, enclosed paddles. This art here is really good because it got the inside pterygoid teeth, the double layer of teeth that mosasaurs definitely do have. And so now, how did mosasaurs swim? This is actually what I specifically study. And so mosasaurs, as they went through their evolution, probably actually went in this exact direction, going from what's called anguilliform or eel-like swimming to kind of in between subcarangiform and carangiform swimming, which only just means where the wave starts on the body. So does a mosasaur generate its body sideways motion for swimming from closer to the head or closer to the tail? Probably somewhere along the middle way, where it's turning its body side to side, using its big tail fluke and its elongate streamlined body to displace water as it moves through the ocean. And so the mosasaur family tree is pretty broad. This is a simplified version here. So we have these three types of mosasaurs, which are more well known. And then you have a mosasaur relative here that was less aquatically specialized. So over here, there are mosasaur relatives that weren't really swimming in the open ocean like the ones that we think of. And then these mosasaurs here and all the ones like it are mosasaurs that are more closely related to mosasaurs like Halosaurus and Mosasaurus. Then these mosasaurs here, which are going to be mosasaurs that are more closely related to mosasaurs like Tylosaurus than they are to these mosasaurs here, Mosasaurus and Halosaurus. And when we go kind of deeper than that, this is what's called, these are called phylogenies, what paleontologists and evolutionary biologists use to depict evolutionary relationships, kind of shows the range of many well-known mosasaur species. And this kind of group of mosasaurs associated with Mosasaurus, so more Mosasaurus like Mosasaurus, is called Mosasaurinae, and that includes well-known Mosasaurs like Clydastes, Globidens, Prognathodon, Plotosaurus, and of course the type name specimen Mosasaurus. And then down here, this name is kind of iffy, but for the most part, it just means mosasaurs that, again, are more close related to Tylosaurus than they are to Mosasaurus. And then you have Halosaurus here, which were actually pretty different. They were quite small, and they didn't have as developed forelimbs. So they were not as aquatic as these types of mosasaurs here. So that's the mosasaur family tree. And my favorite mosasaur is actually a Plotosaurus, because it's one that I get to work with very closely in California, because it's actually associated with California fossils. They're known from formations here, and they're very fishy in their shape. Their skull actually is quite different from kind of the larger, more robust mosasaurs, and they actually look a lot more like an ichthyosaur, which is a fish-looking marine reptile of the Mesozoic, than they do to kind of other mosasaurs. So I like them because they're unique among mosasaurs. And some more mosasaur fun facts as I get to the end here is that mosasaurs were discovered before dinosaurs. I did mention that before, but the specifics are that the first mosasaur was described from 1764. It was discovered near Maastricht in the Netherlands. And in fact, that town is what the Maastrichtian stage of the late Cretaceous is named for, which is the last geologic time zone of the Cretaceous before everything, all the dinosaurs and mosasaurs went extinct. They're the biggest lizards to ever live. Hopefully I conveyed that before when I told you that Mosasaurus could get up to 50 feet long. That's a lot bigger than the biggest living lizard we have today. which is going to be the Komodo dragon, a lot bigger than the longest snakes in the world, like reticulated pythons and anacondas at 25 feet. So they were really, really impressive animals. And they probably had forked tongues, actually. This is a really cool fun fact. I had a ball learning this recently. And it's just because of where mosasaurs are placed in the lizard tree and also based on their anatomy. Their palate anatomy, or the inside of their mouth, bones show spaces for the forked parts of the tongue to go into and interact with the Jacobson's organ, which is what snakes and lizards use to translate the particles they capture on their tongue into scent interpretations. So because snakes have forked tongues and the lizards that are most closely related to snakes and mosasaurs have forked tongues, there's every reason to believe that mosasaurs also had some type of forked tongue. And what's interesting is that sea snakes, which are currently the most marine lizards that live today, do use their forked tongues for gathering scent underwater. So it's easy to picture a mosasaur doing that too. And so the Rutgers Geology Museum, which I was so grateful to have an internship back there when I was a student, has mosasaurs on the wall. They're some of my favorite specimens there, so definitely check them out when everything is back up and running again. And so now, why do we care about mosasaurs? Well, they are great models for understanding the evolution of animals that went from land to sea. And so these are called secondarily aquatic tetrapods. And so these are animals that are descended from four-limbed vertebrates on land that went back into the water. And when I say back into the water, I simply mean that because all four-limbed vertebrates that live on land today are descended from marine species. That kind of first walking fish is the ancestor of all living tetrapods, all living four-limbed land vertebrates. And so other examples of secondary aquatic tetrapods are whales, manatees, seals, and sea lions. Many extinct animals, like I mentioned before, ichthyosaurs have land ancestors, plesiosaurs as well. And mosasaurs are, again, really good models because we have such complete fossils of them. And we have a nice set of fossils spanning from the early parts of their transition to when they were most aquatic. And so again, they have great fossil preservation, so we can ask cool questions about their evolution, but also about how they moved, their diet and ecology, and other detailed questions about their morphology. There's even studies on paleopathologies, which are kind of diseases and other kind of things that show up in bones on mosasaurs that show that deep diving mosasaurs actually got the bends when they would come back up from water, which is really cool. The bends, of course, is when you kind of go scuba diving, you come up too quickly, and then the gas in your body expands too fast. So mosasaurs actually would have had some of that as well. So mosasaurs, great fossil preservation. We can ask really amazing paleontology questions about these animals. And also just because they're extinct, but very closely related to animals that we have living with us today. Again, if anyone watching this at home has a pet lizard, you can look at your pet lizard and be like, oh, you're related to mosasaurs, which I think is one of the coolest things that you can do. And so as far as future work on mosasaurs go, well, there's always new fossils being found. And recently, in fact, the mosasaur from the Arctic was described, which I explained before, which has cool implications for mosasaur ecology and evolution. And so I always look forward to new studies like this, just based on new discoveries and paleontologists going out and doing the field work to bring back these amazing specimens. And currently, like I said before, I actually study how mosasaurs swim. That's specifically my relationship to mosasaurs. And so my co-authors and I were working on a broad comparison of mosasaur swimming changes throughout their evolution, specifically looking at things like performance trade-offs. So how much burst they were getting, how fast they could go, cruising speeds, things like that. That's currently what I'm working on. And so that's pretty much my intro, and I am so excited and ready for questions. I've been seeing some pop up in the chat this whole time. And yeah, so I think that's it. All right, let me pull up the chat box. Okay, let me scroll up. Okay, so the first question.
Kiersten, you can.
Yeah. Okay. Right. Let me stop sharing. There we go. Okay. All right. Actually, just give me 1 second. Let me pull up everything. Okay, Lauren, does that look good for as far as you can tell the way it
Yep.
is? Okay, cool. All right, so first question is from Lauren Barron in the chat. So Lauren asks, where do you begin looking for fossils? So that's a really good question and one that paleontologists get a lot. It's actually why we start with geology and why, even though I'm a biologist, for the most part, I study animals more than I study rocks. Why I'm featured as part of an Ask a Geologist panel is because paleontology is tied to the rocks. And so geologists and paleontologists do the work to tell us what the ages of these rock formations are. If they're late Cretaceous, if they're Triassic, if they're from the Cenozoic. And once we determine what the ages of rocks are, it's very easy for paleontologists to go in and start looking for fossils. If they're looking for marine reptile fossils of the Cretaceous, then you need to go to Cretaceous marine sediments that the geologists determine. It happens the opposite way as well, where sometimes you just find a fossil and then you're able to determine what the age of the formation is based on that fossil, but they work together. So paleontology, paleobiology, and geology all work in tandem to kind of figure out what the ages of the rocks are, what the depositional environment is. So if it was land, freshwater, marine, and what fossils live there. So hopefully that answers your question. All right, and so next question is from Carol Drews from Nolan Lake, Kentucky, near Mammoth Cave. Oh, no question yet that I can see, just introducing. Hi, Carol, okay. All right, and so.
Kiersten, you can check the Google Doc.
Okay, cool.
All the questions are there.
Awesome. Okay, were you guys putting in questions from the chat into that as well?
Yes, they're all in one place for you.
Awesome. So okay, there's Carol's question. Okay, so Carol asks, would mosasaurs also have the jaw like snakes that can expand to ingest their prey? What about venom glands or specialized teeth to inject it like snakes? That's a great question, given that snakes and mosasaurs are each other's closest relatives. From what we can tell, we do know that mosasaurs actually did have jaw, like big open jaw kind of hinging capability. So they could open their mouth really wide. I am actually, unfortunately, not entirely sure if they could truly unhinge their jaws like snakes could, but I do know that some of those jaw features are some of the characters that unite them with snakes. So again, I don't know that they could completely separate their head like a snake could. I don't think so, but they definitely have some remnants of those same features that snakes do. As far as venom glands or specialized teeth to inject it like snakes, so far we don't have any mosasaurs that have hollow fangs like snakes do, and venom glands unfortunately don't really preserve in the fossil record, and doesn't seem like there's any venom gland spaces in the skulls that they have. That we have so far. So I would say probably not to venom, but we never know. New discoveries. All right, and so let me go scroll back up to the beginning of the doc. Okay, so Madeline, age 16 from Texas, would like to know, how did mosasaurs evolve? So Madeline, hopefully, as I was going through the presentation, I kind of got some of this preempted for you, but mosasaurs evolved from small lizards that spent time in an aquatic environment, and they became more specialized as ecological space in the oceans opened up. For most of the Mesozoic, which is when mosasaurs lived, you had large marine reptiles like ichthyosaurs and plesiosaurs and marine crocodiles even living in the oceans. There wasn't a lot of space for a mosasaur to make its mark. But towards the late Cretaceous, there started to be environmental changes and reshuffling of the ecological environments, and made some of those other animals go extinct, some plesiosaurs, some ichthyosaurs, and marine crocodiles. So mosasaurs then had the opportunity to kind of invade the oceans with little competition, and were able to diversify from there into big mosasaurs and smaller mosasaurs and shell-crushing mosasaurs. All right, so Next question. Mary from Scotch Plains, New Jersey would like to know, how did the mosasaurs change from land animals to ocean going? What anatomical changes happened? This is a good question because it's actually the exact thing that I study. So the exact changes, which me and other paleontologists have kind of looked at so far, is we know that they shortened their limbs to become paddles. They have a very short humeri, which are going to be your upper arm bone right here. So those shortened up, and the anatomy changes. Again, they went from kind of separate fingers to enclosed paddles so they could displace more water more easily. They elongated their bodies, and lizards are already pretty long animals, but some mosasaurs kind of took that one step farther. They have incredibly long tails, and they also narrowed the frontal area. So kind of the direction that they face the water became very pointy, so they could be more hydrodynamic. So that's a big anatomical change that happened. Some internal stuff is mosasaurs actually changed their pelvis. Some early mosasaurs were actually able to still kind of go on land to lay their eggs. And as they evolved more, they changed their pelvis to be less weight supporting, which kind of freed up the back half of their body for different types of movements. And also likely where they gave birth to live young, to answer part of one of your other questions there. All right, hopefully that answers your question, Mary. All right, so Max Banyan from Philadelphia would like to know, how did they protect their babies in the ocean, and did they behave like any modern day ocean animals? So Max, behavior is pretty hard to determine in the fossil record, only because it's difficult to actually see exactly what they were doing. We can infer behavior from some fossils. For example, in dinosaurs, we have some fossils of dinosaurs that died with their eggs. So we can infer that they have the behavior where they would lay on and protect their eggs just based on the fossil. As far as if mosasaurs would have protected their babies, I have some unfortunate news that some smaller mosasaurs have been found in the bellies of bigger mosasaurs. So they had an inclination for potentially cannibalism within their own species, and then of course other mosasaurs as well. So I don't know the details of if mosasaurs protected their babies at maybe the early stages, like some animals like cobras do, but we do know that mosasaurs did eat smaller mosasaurs. And so as far as if they behaved like any modern day ocean animals, well, we know that they were big open ocean, some of them are big open ocean predators, and so we can kind of compare them to animals like great white sharks, oceanic whitetips, and things like that. Hopefully that answers your questions. So Tony from Somerville, Massachusetts would like to know what makes mosasaurs so fascinating. So hopefully I gave some answers for why I think mosasaurs are so fascinating. I think mosasaurs are fascinating because we know so much about them. They're actually not entirely mysterious, and there's just such great value in knowing about animals that lived 90 to 66 million years ago, as if they were almost right here alongside us. We know we have their skin impressions. We know what their diet was, what they looked like. It's really, really a cool group to study. And again, it's just awesome that whenever I see a lizard or a snake in a zoo, I look at this animal like, wow, you're related to, some of the biggest ocean predators that ever existed. It's just really cool. That's why I think mosasaurs are so fascinating. Okay, so Ria's mom would like to know, how big could mosasaurs get and what were their predators? So the biggest mosasaurs definitely got upwards of 50 feet long. And I would say most mosasaurs, of like the kind of large charismatic ones that we know of, Mosasaurus, Tylosaurus, Prognathodon, were very large animals, so 20 to 40 feet in that range. And so as far as their natural predators go, it was probably other mosasaurs for most of their life until they got to their adult stages, and then other larger marine predators while they were smaller. So it's very likely that sharks were able to feed on mosasaurs. And in fact, one of those really nice fossil specimens that I showed before, the one that was curled, looks like seems to have been scavenged by a shark, either before and after it died. And that was a small specimen. And then there were plesiosaurs in the ocean at the time as well. So plesiosaur, even though they were smaller in stature, they had smaller heads, could probably go after a small mosasaur. So their predators were pretty much anything bigger than them until they themselves got big. And so I see I got the question, why is the Triassic period your favorite? So this is not anything to do with mosasaurs. The Triassic period is my favorite time period because it's when life got really crazy on planet Earth. I encourage everyone to kind of look into it. There are some really good PBS specials on the Triassic. It's after the end Permian extinction, which is the greatest mass extinction on the planet. It killed a lot of living things, most ever. And in the wake of this extinction, animal life, particularly in reptiles, got so strange. We're talking giant terrestrial crocodile relatives in the same family. These crocodiles would walk on 2 legs like dinosaurs and 4 legs like bears. We got some really strange animals called tanystrophiids, which had exceedingly long necks, some of the longest neck to body ratios of any animals. And then the Triassic, the end of the Triassic extinction is what made way for the dinosaurs. But the Triassic was really when the Mesozoic started to get cool. Then the dinosaurs kind of took over and got the attention away from the Triassic. But Triassic is definitely the coolest part of the Mesozoic. All right, so where was the Plotosaur that you study found? So Plotosaurus was found in California. I believe the first one was found in the Moreno Formation. If not, many are found in the Moreno Formation, which is a late Cretaceous deposit in kind of central California. And so there are mosasaurs that are associated typically with the Pacific Ocean, as opposed to many of the Western Interior Seaway and Atlantic and Tethyan kind of mosasaurs. So that's another reason why I like Plotosaurus. So another question is, how strong were their jaws? That's a tough question. I'm not sure. I don't know that any mosasaur jaw mechanic studies have been done so far, but there are paleontologists that do work on that. I know my advisor has been part of a project to build a really cool robot of a big predatory dinosaur and had bite down on the robot kind of body of another dinosaur to do that. So someone's out there that can determine how strong mosasaur jaws are, but as of now, I'm not sure. I know that they were definitely strong. These were very large animals. They had big, robust skulls, and I would not want to be anything caught in the mouth of a mosasaur. All right, so Maddox from Vermont would like to know, why do mosasaurs have a second row of teeth on the roof of their mouth? So it's hard to ask explicitly why an animal would have something. And there's a good chance that mosasaurs simply have these teeth because they inherited it from their land ancestors. And there was no reason for them to get rid of these teeth. These teeth weren't having any extra negative cost on mosasaurs and probably even help them hold on to squirming kind of aquatic prey. So that's kind of my guess, is that mosasaurs had them because they inherited them and they were good use in the water when you're dealing with slippery fish and other animals that you don't want to get away from you. All right, so another question is, could mosasaurs jump out of the water like was shown in the Jurassic World movie? I think so, and that's actually kind of one of the questions that I'm working on the side. I'm not specifically looking, could mosasaurs breach out of the water? But if we assume that they had similar mechanics as other large marine animals like humpback whales and even basking sharks, which are able to breach and have their bodies come out of the water, then I would see little reason to suggest that a mosasaur, if it wanted to, would be unable to kind of reach the surface. Of course, the one in the Jurassic World movie was huge, but it did not do a totally impossible action, I would say. All right, so another question. Oh, this is a good question. This is kind of my broader PhD project, and that is, what forced land animals to go back into the water. So again, it's hard to answer these specific questions of the causes and the what's and the whys. We have several ideas, which is basically ecological space, that perhaps land was getting too crowded and too much competition, whereas the oceans, specifically after extinctions, may have allowed animals to exploit these open, unexploited resources in the water. So, and we notice that a lot of this happens. A lot of marine invasions, like for things like ichthyosaurs and plesiosaurs, happened after the end Permian extinction. And the oceans were very empty, and they went into the water, little competition, and they were able to diversify. And mosasaurs probably did the same thing. We noticed that mosasaurs start to show up in the water when large ichthyosaurs and large pliosaurs, which were kind of mosasaur looking like things, but they're related to plesiosaurs. They had short necks, big four paddles, and long, scary teeth-filled heads. As soon as those disappeared, we started to see mosasaurs. So it's mostly about things like competition, and then maybe also a propensity for the animals to be able to evolve these features in the first place. So hopefully that answered your question. All right, so Craig Feibel, I know Craig Feibel, would like to know, what do we know about how mosasaurs reproduced? So we do know that mosasaurs, being in the same family and are closely related to snakes and other lizards like that, were terrestrial at some point, and it's likely that they inherited egg laying at early on in their evolution. And later mosasaurs, however, were fully aquatic. And so it would have been possible for a mosasaur to come onto land to reproduce, and you can't lay eggs underwater. So it's likely that these later mosasaurs were giving birth to live young, which is not that crazy among lizards. Actually, there are several snake species that actually do give birth to live young, including big aquatic snakes like anacondas. So as far as the mechanics go, probably similar to what whales do today. And mosasaurs, of course, had hind limbs, which would probably enable them to kind of hold on to each other. All right. So Robin would like to know, did mosasaurs ever have interactions with dinosaurs or pterosaurs? So dinosaurs did not live out kind of in the ocean where mosasaurs were living. Of course, dinosaurs were not aquatic for the most part, but we can imagine, and this happens today, that perhaps a dinosaur may have died on land and a storm or something washes it into a river, and that river washes it into the ocean. It's not impossible that a mosasaur would have an interaction with perhaps a dead dinosaur, or maybe a dinosaur that was kind of island hopping or traveling. I don't know for sure if we have any explicit interactions between dinosaurs and mosasaurs. I think there might be some area, I think of some fossils in Tennessee maybe, where I think they found hadrosaur fossils associated with mosasaur fossils. I'm not 100% sure, but again, the situation I'm confident will have popped up. As far as pterosaurs go, absolutely. Pterosaurs, kind of like seabirds today, were going to be all out in the oceans, flying over mosasaurs, perhaps doing what seagulls do today. When after a mosasaur kills an animal, the kind of pieces will float to the surface, and pterosaurs would maybe fly down and grab some. And I think it has been inferred that mosasaurs certainly would have been opportunistic enough to feed on pterosaurs as well. Again, the situation I'm confident would have existed. I don't know, however, if we have the fossils that explicitly show such an interaction. Okay, so Masha Makarova would like to know, so similar question, why do snakes and reptiles need the inner row of teeth? So hopefully, Masha, I answered that for you before. Again, imagine it's very useful to hold on to slippery prey. Okay, so Max would like to know, why did people start finding fossils? That's a great question, and it really is just luck. Fossils are very old. Ancient human cultures have found fossils, and they interpreted as big, magnificent creatures and inspired their mythology. Things like dragons may have been inspired by fossils. So the why is really just people are very explory people. We dig around, we build things, we clear forests, and then sometimes you find a fossil, a bone that looks like an animal that we have today, and you know that it's a bone, but at the time they maybe did not realize how old it was. But so people just find fossils because people are curious, and we're always exploring our natural world. And yeah. All right, so Robin would like to know, what is the project with the robot dinosaur bite force? All right, so yes, that is, someone put, thank you for the person who put this in the notes, something on the Smithsonian about a nodosaur. I would look at that to look at a dinosaur bite strength and nodosaur. On YouTube, it will definitely pop up. So yeah, that's the project. If not, Robin, if you get in contact with me, my email's online, I can send you the information directly. So just find me there. I'm big on Twitter. Just Google my name. All right. So Tony would like to know, did they lay eggs or give birth to live babies? So I did mention this a little before. They probably did both, not the same mosasaur, but as mosasaurs evolved, they probably went from egg-laying animals when they were still able to go on land. And then once they were stuck in the water and unable to come out onto the surface to have babies, then they probably gave birth to live young. And there are other marine reptiles that we know were giving birth to live babies, things like plesiosaurs and ichthyosaurs, where we actually have fossils of the baby associated with the mother. So probably mosasaurs were doing that. I don't know that if we have those fossils on mosasaurs with live young, but if any of my friends who I told to watch this are watching this, like, yes, we do, please let me know and I'll tweet a correction later. All right, so Sheridan would like to know, hi, Kiersten, asking from New Jersey. Earlier, I stated a specific type of mosasaur was my favorite. Could I explain why that is again? Yes. So Plotosaurus is my favorite mosasaur, and it's my favorite mosasaur because it's really different from other mosasaurs. It is known as a fishy mosasaur because it had a really, really narrow, small head, very fish-like, ichthyosaur-like, and a very long, streamlined body. So it was very pointy fish-like mosasaur, as opposed to kind of Mosasaurus and Tylosaurus, which have these big, frightening, almost crocodile-like skulls. So that's why it's my favorite. Also because it's a Pacific mosasaur, so it's different from mosasaurs that are associated with kind of the East Coast and the Western Interior Seaway, which went through North America. All right, another question. Where have I traveled for my research? So I'm actually I call myself a museum hopper. So I travel specifically to museums for my research to study mosasaurs that people have already found and prepared for us. So they got all the rock off it. So far I have traveled to, let's see what museums I've been. I've been to the Smithsonian in Washington, D.C. I've been to the American Museum in New York City. The Natural History Museum in Los Angeles County is right here. Before I moved to New Jersey, that would have been a big travel for me. And this coming year, and last year I went to Australia, actually. That was for a conference. I went to Brisbane and I went to the Queensland Museum to look at not mosasaurs, but some ichthyosaur fossils. And actually this coming year is going to be my big travel year. I just got some grants that are going to enable me to travel to Europe. And I have to go to 4 museums there to collect my data, as well as travel in the US to Alberta for some fossils that they have up at the oh my gosh, the Royal Alberta Museum, as well as Texas for Dallas-saurus. That's all the places for travel on my list. So I still have a couple of American museums and Canadian museums to go to, and then European institutions as well. All right, so Robin would like to know, would you say that the mosasaur in Jurassic World, one of her favorite movies, is accurate? Okay, so that's a tough question. I don't want to throw shade at the Jurassic World mosasaur because I love, again, that Jurassic World made mosasaurs mainstream. When I tell people that I study mosasaurs, people now say, oh, like the one from Jurassic World, that's amazing. I appreciate that. And it got the double row of teeth correct, actually. So that is accurate. However, the mosasaur is way too big. In fact, the Mosasaur in Jurassic World is probably exceeding the size of a blue whale. When people did like the shot kind of calculations, they interpreted how big it was. And they gave it a crocodile-like scale covering, which is unfortunate because we have Mosasaur skin. We know what their skin looked like. So they kind of went with the sharp scutes on the back to make it look probably a little scarier. And the big thing with the Jurassic World Mosasaur, which is my biggest peeve, it would be almost perfect, or it would be almost excusable, but it doesn't have the tail fluke. It only has kind of a paddle, like an oar-like paddle at the end, which stinks because we know that Mosasaurs had such a tail fluke. And in fact, we definitely knew before the movie came out, or had a really solid idea before the movie came out. So that's kind of my only big issue with the Mosasaur in Jurassic World. But I love the movies too, and I love that the Mosasaur is spoiler alert, is the hero in pretty much both movies, or was the hero in the first movie and was really cool in the second one. All right, so Melissa Boyd would like to know, are you going to the museum in Maastricht? Yes, I will be going to the museum in Maastricht, and I cannot wait to visit the Netherlands. And in fact, there is a Mosasaur meeting where all the Mosasaur researchers get together. And the anniversary, I regret not knowing what the anniversary is, but some anniversary of the Maastrichtian period when it was first named is coming up, I believe, next year or a year or two. And that's actually where we're going to have our Mosasaur and marine reptile meeting. And so I'm very much looking forward to that, and the museum also. All right, and so far the last question I have on my doc is, why did you decide to study Mosasaurs? So Mosasaurs, I will admit, kind of conveniently fell into my lap for research. I've always been interested in marine animals, and specifically the evolution of their transition. The reason why Mosasaurs have become kind of such the forefront of my research is because I have access to Mosasaur specimens here at the museum. So it's been easy for me to kind of start collecting data without having to really go far. And also, again, because Mosasaurs are so well preserved from kind of their very terrestrial, semi-aquatic ancestors to the very aquatic open ocean forms, because that evolutionary range is so well preserved, I can use them to ask and answer detailed questions about the evolution of animals that went from land to sea. They happen to also be some of my favorite, probably my favorite extinct animals, but I didn't study them just because they're my favorite. It just worked out that way. All right, so that's the last question, I believe, that I have on my document.
Okay, thank you so much, Kiersten. That was really cool and interesting. We loved having you speak for us. And for everyone who tuned in today, thanks again for joining us. And don't forget to join us next Thursday, June 11th at 11 a.m. We will have a graduate student from the Rutgers Department of Geology, Lasha Laidman, and he will be speaking to us about the Greenland glaciology. So please don't forget to tune in on Thursday, and thank you again, Kiersten.
Hey, Ria, we actually had we had a buzzer beater question come in. Have you ever been at a dig site where they found a mosasaur, Kiersten?
I have not been at a dig site where they found a mosasaur, but in fact, the director of our museum, Luis Chiappe, is trying hard to kind of reactivate dig expeditions to the Moreno Formation, which is where the Plotosaurus was found. So hopefully soon, the museum in LA, we're trying to kind of get some new marine reptile stuff and have a new dig site where we can take people and have summer things. So hopefully soon, I would love, I've had dreams about finding a mosasaur in the field. Not yet, but it's going to happen, I believe.
Thanks, Kiersten. Have a nice day, everyone.
Thanks. Bye, everyone. Thank you.